All right, so here we're going to start the probability unit already. So our first section is called the empirical and theoretical probabilities. So let's go ahead and just start by going over the definitions because I know the two words kind of seem scary. So the first one is what we call empirical probability. This whole unit is going to be over talking about probabilities, and there's two different kinds that we're going to go over today. So empirical is when you find a probability based on observations. So if I were to go to class one day and I check, okay, how many girls are there compared to how many boys, and I make up a fraction and a probability, it's what we call empirical, since it was based on an observation. Now, the second one we're going to talk about is what we call theoretical. Theoretical is when you obtain it from a study of possible outcomes. So you actually base your probability from possible outcomes. So you really don't know, but you actually come up with it. So that's why it's called theoretical. So the main difference is empirical, it comes from observations, and theoretical, it kind of says it on the name. It's kind of based on like a theory. So you figure out based on what's going to happen in the future. So those are the two kinds. Now, when we're talking about probability, there is going to be a formula we're going to be using. So to find the formula or to find the probability, we're going to be using the formula below. When I ask you, what is the probability of certain thing happening? It's always going to be the number of times the event occurred. It's going to be your numerator. And your denominator is going to be the total number of outcomes. This is the main thing you have to take away from the formula. The denominator is always going to be your total. So if I were to walk into class, right? Just imagine we're in class. And I were to say, how many people are wearing caps? So your numerator would be the number of times the event occurred. So we would count how many people have caps. Let's say there was 3 people. And then the denominator, like I said, it's always going to be your total. So it would be the total number of students in the class, let's say 10. So that would be your denominator. So that's pretty much a simple formula. Again, I know it looks very scary the way it looks there, but that's what we're going to be doing. So again, number of times your event occurs is going to be your numerator. Your denominator is always going to be the total. So let's go ahead and see if we understood what happened. Here we have an example. Let me just go ahead and read it. We have a fair coin was tossed 200 times and it landed heads up 110 times. Find the empirical probability for the coin landing heads up. Before we tackle the problem, you notice they're asking us for empirical because it's based on observation. Someone actually had enough time to toss a coin 200 times. So it's based on those observations, and we found out that it landed heads 110 times. Now they're asking us find the probability. So again, don't freak out. We're going to be using the same formula we saw earlier. Remember, the total is always on the bottom, and the number of times the event occurred goes on top. So now take 5 seconds, see if you could determine what's going to be the numerator, what's going to be a denominator. Okay, that was 5 seconds. So pretty much, again, the total is always on the bottom. So hopefully you said that the total, which was being the 200 times that it was tossed, is going to be my denominator. Now, out of those 200, they're asking us find the probability that it's going to end up being heads up. So they're telling us that it landed heads up 110 times. So that's all you have to do, 110 over 200. But again, in this time, we're going to express probability as a decimal. So all you have to do is grab your calculator, go ahead and put 110 divided by 200, and you should get 0.55. Right, so that is my probability. We've already talked about several times how to make a decimal into a percent. In this page, it's not going to be needed, but just know that that's how you get it. So again, 110 divided by 200, put it in your calculator, compute it, and you get that 0.55 is the probability. All right, so that wasn't that bad. Now, I can get the same problem, change it up a little bit. That's what we're going to do in the next slide. So, same problem. Let's see if you notice what I changed. So a fair coin was tossed 200 times, so this stayed the same, and it landed heads up 110 times. So it's the same scenario from earlier, but now the actual question is find the probability, oops, you get it, that it landed tails up. So if you notice in the last problem, I asked you for heads up. Now I'm asking you for the probability that it landed tails up. So if you're familiar with coins, which hopefully we all are, a coin has heads or tails, right? It has to be either or. So if they tossed the coin 200 times and it landed heads up 110, how many times did it end up being tails? Okay, that shouldn't be that much of a problem. Just pretend you understand what I'm writing here, but To find tails, you would just do 200. You would subtract the 110 times that it landed heads up, and that should give you the total amount of times that it ended up being tails. So if you do that, you will find out that it ended up being tails a total of 90 times. Right? Again, pretend that was beautiful handwriting, but you get it. So again, the problem doesn't have the number 90, but you have to know how to figure it out. So if it ended up being heads 110, that means it ended up being tails 90 times. Now, how do we find probability? Probability is what I'm asking you for, goes in the numerator, and then the total goes in the denominator. So my answer for this one would be 90 over 200. But again, since we are expressing probability right now as a decimal, you just simply divide that. So your calculator, go ahead and put 90 divided by 200, and you should get that it ended up being tails a total of 0.45 percent, right? Well, this is not in percent, but you should know how to make that into a percent. So hopefully this is all making sense. Again, these are the baby problems still. Just knowing that you have to make a fraction to get your probability. All right, so that was pretty simple. Now, before we move on to other problems, we do have to review a few little probability facts, right? When we're talking about probability, this is the chance that something is going to happen. So if there is no chance that an event is going to occur, the probability is 0. So probability could be equal to 0. Sometimes there's no way something's going to happen. So if I ask you, what's the probability that right now, in the middle of this video, George Clooney is going to come up and interrupt me, right? Okay, that did not happen. So pretty sure the probability of that happening is 0. So probability could be 0. Probability could also end up being 1, meaning that the event is most likely to occur. So when something's not going to happen, the probability is 0. When something is for sure going to happen, the probability is 1. So just know the probability could range from 0 to 1, and it could be 0 and it could be 1. So again, like I just said, probability ranges between 0 and 1. The word inclusive there, don't let it scare you. Inclusive just means that it could be 0 and it could be 1. So pretty much if I ever ask you, what's the probability of this happening, and you give me a negative number, there's no such thing. If you give me a number bigger than 1, there's no such thing. Probability is always between 0 and 1, could be 0, could be 1. So those are little things you do have to know about probability. And the last one, the sum of probabilities always has to add up to 1. So when I ask you, what's the probability of getting heads or tails? Normally it would be 50-50 chance. If you add 50 and 50, you'll see it adds up to 100%. So that's what we mean. Probabilities always have to add up to 1 in decimal form, or they always have to add up to 100% if they're in percent form. Okay, so little things you do have to keep in mind when you're giving me answers. They have to be between 0 and 1. They have to add up to 1, and it could be 0, it could be 1. Pretty much that's everything we have to do about probability. Now, something else you do have to know. Probabilities have to add up to 1, just like I said. So here I have the same thing I said in the earlier slide, but in formula format, right? So the probability of something happening plus the probability of something not happening has to add up to 1. If you're talking about percents, then the probability of something happening plus the probability of something not happening has to add up to 100%. So if I tell you the probability that I am going to eat cookies today is pretty much 90%. What is the probability that I'm not going to eat cookies? Well, then you should know it's 10% because the 90 plus the 10 has to add up to 100%. So again, when I ask you, what's the probability of something happening and something not happening, you should know they always add up to 100. If we're talking about percent, if I give it to you in decimal, they have to add up to 1. Okay, if that made no sense, don't worry. Let's go on to an example and you'll see what I mean. So here we go. Example number 2. If the probability that it will rain is 0.55, what is the probability that it will not rain? So again, first thing I want you to notice is I give you the probability in decimal format. There is no percent sign, so we know that we're going to be using this formula, right? Because it's the one that has in decimal. So the probability of something happening plus the probability of something not happening has to add up to 1. So if the probability that it will rain is 0.55, what is the probability that it will not rain? You should know what to do. So again, we're going to be using this formula. The probability that it will rain plus the probability of not raining has to be add up to 1. The problem gave us the probability that it will rain, which is 0.55. So how in the world do I figure this one out? If I know that 0.55 plus this magical number I don't know has to add up to 1, how do I find out that number? Okay, hopefully you're saying, oh, you need to subtract. Yes, we do need to subtract. So to find the probability that it will not rain, you just do 1 minus the 0.55, which should give you 0.45. So again, some of you will get this very quick. Just by looking at the number, you could find the other number. That's okay. If you have no idea what's going on, the formula is here to help you. Every time I ask you for probability of something happening, something not happening, they have to add up to 1. So the probability that it will rain is 55. The probability that it will not rain is 0.45. Okay, so again, I know I did a lot of work here, but I was just trying to break it down. From now on, all you have to do is just 1 minus the probability that is given, and that will give you the answer, which is to the probability that it is not going to rain. Okay, hopefully that made sense. Again, if it did not, don't worry, there's one more problem coming up. So this was in decimal. Now there's a problem in percent. So I want to see if you guys know how to do it differently. So example number 3 says, a recent survey shows that only 12.4% of a city's population has completed the census. What is the probability of randomly selecting someone who has not completed the census? So again, as soon as you read that question, you should know, okay, we're going to solve it using the 100% that they have to add up to. Because again, I'm giving you the probability in percent that someone has completed the census. The question is, what is the probability that someone has not completed the census? So I give you part of it, you have to fill in the other part. So again, as soon as you see a percent, you know we're going to be using the formula with the percent sign. So the probability that someone has completed the census plus the probability that someone has not completed the census has to add up to 100%. Again, because that's the idea of probability. They always add up to 100. So in the problem, they're giving us the probability that someone has completed, which is 12.4. How do I find the missing one? Same thing we did earlier, we just subtract. So to find the probability that someone has not completed the census would just simply be 100 minus 12.4, which gives us 87.6. All right, so again, same thing as the last problem, but one was in decimal, one was in percent. Okay, so hopefully this is all making sense. But again, this is just the intro. So how to find probabilities, just remember they always add up to 100%. All right, now moving on to the good stuff here. So we're going to start tackling some problems, a bunch of problems actually, that have to deal with probability. So here we're going to be talking about dice. Just so you know, probability has to do a lot, or not has to do a lot, but we use a lot of dice and deck of cards because they're easy to create probability problems from them. Again, I'm not encouraging you to go gambling. That's not on me. We're just using the problems for the probability section. So in the first problem, imagine you have a die with you, right, which is singular for dice. You roll it, and the question is, what is the probability of rolling a 4? These problems are super simple. Don't go overthinking them. So if you roll a die, hopefully you're familiar with a die. It has 6 sides, right? In one side, it has a 1, it has a 2 on the other, a 3 on the other, and so on all the way to 6. So here are all the possibilities you can get when rolling a die. So what is the probability of rolling a 4? Just ask yourself, how do you set up probability? Remember, probability is always a fraction. So in this scenario, what is the probability of rolling a 4? Well, the numerator is going to be the number of 4s in a die. And remember, the denominator is always your total. So just think about it. If you have a die, how many sides does it have? It has a total of 6. So it goes from the number 1 to the number 6. So that is the total number of outcomes. So the total number of outcomes in a die is 6. So that's going to be my denominator. Now in that die, how many sides have a 4 on it? Because that's what they're asking us for. So if you look at a die, or you could just cheat and look at the picture, only one side has a 4 on it. So there's a 1 in 6 chance that we will roll a 4. So it's pretty simple. You just have to be familiar with the die. So again, when I ask you for probability, what's the probability of rolling a 4? There's a total of 6 options. So that's my denominator. Out of those 6 options, only one of them is a 4. So that's the number 1 on top. So pretty simple. Again, make a little note. When you give me a probability in fraction form, it has to be simplified. So in this one, we're going to leave it as is because it's already simplified, but if it wasn't, you would have to simplify it. Make sure to give your answer in simplest form. All right, so hopefully we feel okay with this one. Let's go ahead and move to number 5. If a fair die is rolled, so again, same scenario. What is the probability of rolling an odd number? So again, probability is a fraction. So my fraction is always going to be the total on the bottom, and what I'm asking you goes on top. So hopefully we all know now that since we're talking about a die, the total possible of outcomes is 6, right? There's a total of 6 options. There's 6 sides. That's always going to be my denominator. Now, out of the 6 options in a die, how many of those are odd? Okay, if you have no idea what odd means, odds are numbers like 1, 3, 5, 7, and I could keep on going forever, but you get it. Right, so even numbers are 2, 4, 6, 8, and so on. Odd numbers are 1, 3, 5, 7, 9, and so on. So if I roll a die, what is the probability of rolling an odd number? Out of the 6 options in a die, how many of those are odd? So let's look it up. So this one is odd. The 3 is also odd. The 2 is not. The 4 is not. The 5 is odd. And the 6 is not. So out of the 6 options, how many are odds? Well, we have a total of, that's an ugly 3, but you get it. So there's 3 options out of the 6 that are going to be odd. And like I mentioned earlier, when you have a fraction, make sure it's simplified. So 3 over 6 can be simplified by 3 to give you your final answer of 1/2. Right, so again, when I ask you for a probability in fraction form, make sure it's reduced. I would not count it wrong if I ask you what is the probability, you tell me 50%. Because remember, 1/2 as a decimal, 5. Oh my goodness, you get it, right? 0.5. And that as a percent, I don't even know why I'm still trying, but oh well. That as a percent is 50%. So sorry for the little kid, but there we go. Right, so again, I would not count it wrong since the question specifically didn't ask to express your answer as a fraction, a decimal, or percent. So either one of those would be right. But when we do give you a homework or an online assignment that specifies to leave your answer as a fraction, make sure you leave it the way they're asking you for. So again, my answer was 1/2 because it's a simplified fraction. You could make it into a decimal, 0.5, or you can make it into a percent, which is 50%. Okay, I'm pretty sure you guys are getting good at this already. So let's try the next one. If you roll a die, what is the probability of getting an 8? So out of the 6 options in my die, how many of those are 8s? So hopefully you just looked at this question, you're like, that is impossible. You are correct. When you roll a die, there is no way to get an 8 unless you have one of those weird dies that I have no idea where they exist, right? But a normal die would have no 8s on it. It just goes from 1 to 6. So if you remember what we talked about earlier, the probability could be 0 if it's never going to happen, or it could be 1 if it's always going to happen. So this is one of those scenarios where my probability is going to end up being 0 because there is no way that if I roll a die, I'm going to roll an 8 because we're talking about a fair die, right? Like the normal standard dice out there. So my answer for this one would be 0. Again, you could use the same format we've been using. There's a total of 6 options in a die, but how many of those are 8? Well, none of them. And that is still going to give you the 0 that we were looking for. All right, so but again, you don't need to write it as a fraction. There's no need to. If you could just look at the problem and tell me there's no way that's going to happen, that's a straight up 0. That's all I need. Okay, so again, sometimes probability is going to be 0. That's okay. All right, moving on. Let's go ahead and try one more. Please do not get confused with this one. Read it slowly and see if you could understand what they're asking us for. So on this one, if a fair die is rolled, same thing. What is the probability of rolling at least a 5? Okay, so I'm going to read that again. What is the probability of rolling at least a 5? Make sure you read that through and understand what they're asking us. What does at least a 5 mean? Okay, this is where people are going to start arguing. Well, that means this, that means that. At least a 5 means that it could be a 5 or it could be more. Okay, I know it has the word least in there. That does not mean 5 or less. It means 5 or more. Again, if you don't understand that, let me just see if I can come up with a scenario. So, at least a 5. Let's say I need money and I go to you and I ask you, hey, I have an emergency. I need at least $5. You can lend me $5 or you can lend me more because I told you at least. That's the minimum. So it could be 5 or it could be more. Hopefully that made sense because that's as creative as I can get. At least 5, it could be 5 or more. So again, you tackle the problem the same way we've been tackling all the problems. It's going to be a fraction. So in a die, what is the total possible of outcomes? Hopefully we all agree now that it's 6. You have a total of 6 outcomes. And how many of those are at least 5? Meaning 5 or greater. So let me come back to my die here. 1 is out, 2 is out, 3 is out, 4 is out. 5, is 5 at least 5? As weird as it sounds, yes, because at least 5 means you could have 5 or you could have more. So we're going to include the 5 and the 6. So how many are those out of all the 6 possible outcomes? That's a total of 2. Okay, so I'm going to take a few seconds here just to help you process that. My die has a total of 6 options, all the way from 1 to 6. How many of those are 5 or greater? Well, it's just the 5 and the 6. Those are the only ones that qualify for the requirement that they're giving. So at least 5 means 5 or 6. That's a total of 2. And hopefully we all know how to simplify that. 2 over 6 becomes 1 over 3. So that would be my answer for that. Okay, so be careful with those. This is probably as tricky as it's going to get. Make sure you know what at least means. At least means that number or greater. All right, so enough with dies. Let's go ahead and make this a little better now. Again, yes, I'm hungry. That's why these problems have chocolates on them. I'm so sorry. So in this problem, we have a bag, right? The bag contains a total of 58 M&Ms, 31 Reese's, 26 Kit Kats, and 45 Almond Joys. All right, so we have a bag that has all of these candies in it. Now the question is, if you were to put your hand in there and select one candy out of random, what is the probability that the candy is an Almond Joy? So again, these problems are all the same. You set it up the same way we've been setting them up. So remember, your total is always going to be on the bottom. Now, what in the world is going to be the total? I don't give it to you on the problem, but you should be able to figure it out, right? If there's 58 M&Ms, all you have to do is add it to the 31 Reese's, add it to the 26 Kit Kats, and add it to the 45 Almond Joys. That's going to give you your total, which is going to be my denominator. So if you add up all of those numbers, you should get a total of 160. So look at that. The problem doesn't give you the total, but you should be able to figure it out. So add them all up together. That's the total. So I have a total of 160 candy. Now the question is, what is the probability of selecting an Almond Joy? Hopefully there should be no problem at all. How many Almond Joys are there? There's a total of 45. So that's what goes in the numerator. So 45 candies out of the 160 total are Almond Joys. So there we go. That's our probability. Again, remember when I give you a fraction, make sure it's simplified. So 45 over 160 becomes 9 over 32. Again, you should already know how to simplify these. If you don't, just remember what's the number that goes into 45 and 160. You should see that they're multiples of 5. So you simply divide both numbers by 5. And that's how we got the 9 and the 32. Again, you would have to keep on going, but there's no number that goes into 9 and to 32, so that's already your simplified answer. Okay, so hopefully that made sense. So again, remember the same procedure. Your total goes on the bottom, and your number depending on what the problem's asking you for, goes on the numerator. And then simplify and you're good to go. All right, same problem, let's just change it up. Same scenario, we have the same amount of candies. What is the probability that it will be a Kit Kat? So you should know how to do this already. You have 5 seconds to see if you could find the answer. Okay, you should have an answer already, right? So again, same procedure, same thing. The total amount of candies, I'm going to cheat. We had already found it earlier, which was a total of 160. And out of those 160, how many are Kit Kats? 26. And remember, that's not your final answer because you have to simplify. Those two numbers are even, so you can divide them by 2. And that's how we got the 13 over 80. So again, nothing tricky about this, just making sure you know how to set up a probability problem. So total goes on the bottom, the number I'm asking you for goes on top, and then you just simplify. Okay, pretty simple. All right, moving on. Like I told you, I'm not promoting gambling, but deck of cards just gives itself to be a probability problem. So if you're not familiar with a deck of cards, again, don't go gambling thinking that, oh my goodness, it's going to help me for my contemporary course. I am not promoting that. Don't you dare say my name at all. I'm just going to make you familiar with the cards, right? So a deck of cards has a total of 52 cards, and there are 4 different suits, right? The first suit is what we call as spades, and they're black, and they go from 2 to 10 in numbers, and then we have an ace, a jack, a queen, and a king, right? And the same thing repeats for the clubs that are also black, and then the same thing repeats with the diamonds and the hearts, but the diamonds and the hearts are red. Right, so here's a picture. That's what a deck of cards looks like. Again, because the way they're set up, it's very nice to use probability problems with them. So we're going to go ahead and do that. But here's a picture, and I'm going to have the picture on every slide so we could just use it. So that's what a deck of cards looks like. All right, so pretending we have a deck of cards. If I were to throw them all on the table and I just mix them around and I ask you to grab a card, what is the probability that you will select a card that is a 7? Okay, so again, same thing over and over again. You're going to set it up the same way we do with the Kit Kat problem, with the dice problem, with any single problem. Your total always goes on the bottom. So I'm not going to make you count the cards, right? But remember, a deck of cards, if you don't remember, let's go back to the previous problem, has a total of 52 cards in total. So my denominator is going to be 52. That's a very ugly 5, but you can read it. 52. Now, out of those 52 cards, how many are 7s? So I'll give you a minute to count that. How many 7s do you see there? There is only a total of 4 7s. There's 4 different 7s out of the whole 52 cards. So there is 52 cards in total. That's why it's my denominator. And out of those 52, 4 of them are 7s. So that's my numerator. Super simple. But again, hopefully you're stopping me because you're like, that's not the answer, right? Remember, you always simplify. So 4 and 52 can both be divided by 4. So 4 over 52 simplifies to 1 over 13. So that's our answer. Pretty simple. All right, just to make sure this made sense, let's go ahead and try one more here. In the same deck of cards, what is the probability that you select a card that is not a 7? So what in the world, right? Last question asked us, what's the probability that it is a 7? What's the probability that it's not a 7? So again, same procedure. My denominator, hopefully you see that is still 52 because there's still a total of 52 cards. Now, out of those 52, how many are 7s? I'm not going to make you count them, and hopefully you shouldn't. If there is 4 cards that are 7, how many, that was supposed to be an arrow. There we go. If there are 4 cards that are 7s, how many are not 7s? Hopefully you should notice that that is a 48, right? If you have 52 cards and 4 of them are 7s, subtract the 4, and that tells you that the 48 cards remaining are not 7s. So that's all you have to do. So that's our answer. Of course, you do have to simplify. So 48 over 52 simplifies to 12 over 13. Again, you should know how to simplify, but if you can't, both of these numbers can be divided by 4. So that's how we got the 12 over 13. Some of your calculators will simplify a fraction for you. You're more than welcome to do so. But I just want to make sure your answer is always simplified. So my answer for this one is 12 over 13. Not bad, not bad. All right, let's go ahead and try a couple more just with the deck of cards. If one card is selected at random from a deck of cards, what's a probability that the card is a heart? Right, so there's again a total of 52 cards. Out of those 52, how many are hearts? All of these are hearts, right? You could count them, or you could just remember what I told you earlier. There are a total of 13 cards for each suit. So my answer is just 13 over 52, which simplifies to 1 over 4. Okay, so what is the probability of getting a heart? Count them, 13 over 52, you simplify. Pretty simple. All right, next one. Ooh, this one gets better. Look at this. If you select a card at random, there's a little tricky part in here. What is the probability that the card is a jack? Or, that's going to play a big thing there, a queen or a king. So, hopefully you're already familiar with the word or. Or means either or. So it could be a jack, it could be a queen, or it could be a king. So how many of the 52 cards in total fit that category or that requirement? So let's check it out. There's a total of 4 jacks. There's a total of 4 queens. And there's a total of 4 kings. So we have a total of, hopefully you know how to add those. We have a total of 12 cards that fit this requirement. So how many of the cards are jacks or queens or kings? Add them all together, there's a total of 12 cards that fit that requirement. So my answer would be 12, which is right here, over the 52 total. So that's our answer, but of course, we simplify. So you simplify, this simplifies to 3 over 13, so that would be our answer. Okay, I'm gonna take a step back, just gonna go over it again because I know this one's a little tricky. When you have the word or, it means it could fit either one of the categories. So it could be a jack, it could be a queen, or it could be a king. So I counted all those cards, there's a total of 12. You put them all together, so that gives me 12 over the 52 total, which simplifies to 3 over 13. So when you come across the word or, don't panic. It just means either or. So it could be a jack, or it could be a queen, or it could be a king. So you put all those together and that's how you get your answer. All right, hopefully that went through. Hopefully you understand that part. Because there's one more problem in there dealing with cards that I just have to make sure we understand. So there is a difference between the word or and the word and. Okay, I'm going to read this question. I want to see if you guys get it. If one card is selected at random, what is the probability that the card is a heart and diamond? So be careful. This does not have the word or. In the last problem, when you have the word or, you add the number of jacks plus the number of queens plus the number of kings. That's how we got 12. When you have the word and, it means you have to find a card that is a heart and a diamond at the same time. So out of my deck of cards, how many cards do you see that have a heart and a diamond at the same time? So if you're familiar with cards, you should know that there is no card that fits that requirement. There is no card that is a heart and a diamond at the same time. So for this one, you would set it up the same way, but you should end up knowing that it's going to end up being 0. Right? Again, because there is no card that fits being a heart and a diamond. Okay, so my answer for this one would be 0. Again, if you're freaking out, just go back to the last problem. The word or means you add them. The word and means you look for a card that is both of them at the same time. Okay, I don't want you to think, okay, from now on the word and means 0. Not necessarily. This one was 0 because there is no card that is a heart and a diamond. If the question would have been, what is the probability that the card is a heart and let's say a 7? Then there would be a card, right? Here we have a card that is a 7 and a heart. So my answer for this question would be 1 card out of the 52. Okay, so make sure you know the difference. The word and means it has to be both of them, a heart and a 7 at the same time. All right, hopefully that made sense. If it didn't, rewind it a couple seconds and watch it again. But that's all that it means. All right, we're almost there. Hang in there, hang in there. Our last problem, kind of, sort of, is this one. Sometimes the information given to you is not going to be in paragraph form, like the couple of problems we've seen today, but it's going to be in a table format. So before we actually looked at the question, let's go ahead and just familiarize ourselves with the table. So here we have a table that tells us what kinds of products were manufactured and by who. So we have 3 different products. We have laptops, phones, and tablets, and those were manufactured by either company A or company B. Right, so we could see that there's 23 phones that were manufactured by company A. There was 27 tablets that were manufactured by company B. And then they were nice enough to give us the totals. So there's a total of 110 products by company A, a total of 112 products by company B, a total of 92. This comes from the laptops, so 92 laptops, 61 phones, and 69 tablets. And then the 222 means the total of all products, right? So that's how you read a table. So now that we know the table, let's see if we can answer the question. The question says, if you were to select one product at random, what is the probability that the product selected is manufactured by company A? So remember, probability is always going to be set up as a fraction. So I'm going to make my little fraction here, and hopefully we agree to the answer. So let's start with the easiest part, which is the denominator. Denominator is always my total. What is the total amount of products here? They actually give it to us right there, right? So there's a total of 222 products. So that is my denominator. Again, just pretend that is beautiful right there, 222. Now, out of those 222, how many products were manufactured by company A? A lot of them, but what number do we use? So for company A, there was 45 laptops, 23 phones, and 42 tablets. So the way we would do is just add all of those up. But we don't have to add them up because they actually already give us a total. There's a total of 110 products that company A made. So that's it. That's all we have to do. So 110 over 222. And again, you should know that's not our final answer. That simplifies to 55 over 111, which would be our final answer. So again, make sure you read the question carefully. There's no need to add because the table already gives us a total. So how many products were manufactured by company A? 110 out of the total, which was 222. Simplify and you're done. All right, let's see if this made sense. We only have 2 more problems to go. Same table. Now look at the question. What is the probability that the product selected is a tablet, and this word is back, and manufactured by company A? So let's start with the easy part. What's the total? We had already said earlier was 222, so that's going to be my denominator. Now, how many tablets were manufactured by company A? So what number do you think that is? Tablets manufactured by company A. So all you have to do, company A is right here, and tablets is right here. So that means that there's a total of 42 tablets that were manufactured by company A. Again, the word and means it has to fit both categories. It has to be a tablet and it has to be from company A. So my answer would be the 42. So again, probability, super simple, just 42 over 222. simplify. Hopefully you can read it. 7 over 37 would be your final answer. Pretty simple. All right, hopefully that makes sense. All right, one last problem for this section. Very simple again. Same table. Now they're asking us, what is the probability that the product selected is a laptop? So hopefully, first thing you notice is our denominator is going to be 222 because it's still the total. Now, how many of those are laptops? This one's a laptop. This one's a laptop. So we just add them. Hopefully you don't take out your calculator to add them because I already gave you the total right here. So there's a total of 222 products in total. Out of those, we have a total of 92 laptops. So my answer is simply 92 over 222, and then you simplify. Again, you could simplify manually. You would divide by a number that goes into both of them. So in this one, I divided by 2. That's how I got 46 over 111, and then you cannot continue simplifying, so that would be your answer. Again, if you have questions, you could let me know. You could simplify that on your calculator. So you would put 92 divided by 222, and then you would tell a calculator to give you back a fraction. It will give it back to you in simplified form. All right, so hopefully that makes sense. Those were some problems. If you have questions, feel free to go back, look them over, or send us an email if you have questions.